Good afternoon, everyone. I'm Victoria, and the Blue Pythons present to you our final results for our product, Cereal Sentinel. Cereal Sentinel is used to say supermarkets more time. As a restaurant worker myself, I have experience with the stress of walking around all day to satisfy customers. Now imagine what grocery stores workers feel like walking around 8 hours a day to restock and reorganize each shelf. Barbara, can you scroll down for me? Cereal Sentinel is a useful product for grocery store workers. It's inefficient for workers to consistently walk around to search for unorganized or unstocked shelves. And so we made a product that will detect unorganized shelves or aisles that need to restock. I will now pass it on to Barbara.
Okay, it's now time for you to meet the team. Of course, I will start off with myself. Hi, I'm Mahnoor Babra, and I'm a rising sophomore at Maryland F. West High School, and I was also the front-end designer of the group. Next, we have Victoria Lee, who is also a rising sophomore at Clark High School, who was the front-end engineer and visionary of the group. We have Kevin Kim, who is also a rising sophomore at Brenham High School, who was a back-end developer of the group. We have Daniel Mercier, who is a rising 7th grader at Helen Stacy Middle School, and he was also our product manager. We have Danzel Ngo, who was a rising freshman at Oakland Charter High School, and he was also a backend developer alongside Kevin Kim. And we have Ethan Lee, a rising freshman at Evergreen High School, who was a data scientist of the group. And last but definitely not least, we have our mentor, Adam Mehdi, who is currently pursuing Bachelor's of Science at Columbia University. Without his help, this project would not have been possible. It's now time for you to see the project in the works with Kevin Kim.
All right, so based off the picture that we put into our demo, here's what we found. So the aisle has been marked with the label restock ranging from 64% to 31% with confidence respectively. And we have a few more examples that we can put up for you. So this is our second picture. Do you mind scrolling down a little bit? Yeah, okay, so here's what we found. So the aisle has been marked with the label disorganized and restock ranging from 48% to 26%. And we have one more example for you.
Sorry, hang on. Technical difficulties. I'll just read you the site.
Okay, so this is our last photo. So this aisle has been marked with the label restock, with ranging from 58% to 39%. Okay, so you might be wondering, how does the Serial Sentinel work? Basically, our team collected images from Google Images and then labeled them using RoboFlow. We trained YOLO v5 on the dataset and then put our trained model onto this website. So the graph on the right you can see is that it has a ratio between precision and recall, and on the top right is like a key showing what each line represents. So at our confidence threshold, our model has a precision of approximately 0.8 and a recall of approximately 0.1.
Quick question. What is more important in this case, precision or recall?
We'll get to that later on.
Okay.
Yeah. Mm-hmm.
Okay, and secondly, for evaluation, we trained our YOLO v5 using Google Colab's GPU and evaluated it using like weights and biases. We trained 3 runs and found out that our second run performed best. And so to the right, you can see there are some of our plots from our second run. We can also see that the training losses decreased consistently with epochs, which is on the x-axis, but the validation losses increased. However, this behavior is like consistent with like overfitting, so therefore we used a model weights of epoch 42. I'm gonna be passing it on to Danzel now.
We used SERP API to scrape images from Google Images. Then we used RoboFlow to label the images and apply several data augmentations. As illustrated at the right, our model suffers from class imbalance and noisy labels. We ran into this class imbalance because Google Images is more likely to display serial aisles in need of restocking. While out of place and disorganized objects are less prevalent, we also have many different labels for restock and disorganized. However, in our subsequent iterations of training where we removed the noisy labels, the models performed worse. Hence, we kept the redundant labels.
Confusion matrix. The confusion matrix underscores the precision and recall metrics. Our model's high precision means that any prediction our model makes is likely to have a corresponding true label, but its low recall means that our model receives only a fraction of true labels, as seen as on the right. This ideal behavior for an understaffed grocery store, because it means that an employee will not be barraged with false notifications that a cereal aisle needs attention.
By the way, that answers your question, Richard. Precision
Yes, it
is
does.
probably more important. Yeah.
That's cool. Thank you.
And that concludes our website. We hope you liked our product by the Blue Pythons, again, for the efficiency of our local supermarket. And yeah, thank you for listening.